So today we're going to talk about polar coordinates. Polar coordinates are actually quite important to understand and to be able to use. You'll see them a lot in Calc 3, so it's good to get a thorough grounding in them. But what's the idea? The idea you probably already know, or you've seen them already. It's this idea of we can give our point in space. Here's my point in space. We can give it Cartesian coordinates x and y, right? So x is the distance along this axis and y is the distance along that axis. But we can also, given any point in space, give it coordinates on the basis of r and theta as well, right? So, meaning r being the distance here to, there you go. So we know that r is the square root of x squared plus y squared. Pythagorean theorem. We can just write it this way if we like, rather than having that square root sitting there, okay? And what about theta? Well, you can do x equals r cosine theta, right? So you got x equals r cosine theta, and y equals r sine theta. And in fact, you guys, we kind of looked at this a little bit with complex numbers as well. But this is now just in the real plane, right? So you can, given some r and theta, you can figure out the x and y. Given the x and y, you can figure out the r and theta. Using this, also, if I want, I can say that tangent theta is y over x. So these are basically, given r and theta, we can get to x and y. Given x and y, we can get to r and theta in this way. Okay? So that's not that bad. I will say the one thing that's interesting about polar coordinates and also somewhat annoying is, unlike the Cartesian coordinates where you know exactly each point has a unique x and y, here each point can have multiple values of theta, obviously, and even two different values of r. I will say this, the confusing thing for a lot of people is using negative values of r. You don't see that much in Calc 3. We kind of try to avoid it if possible, just because it makes everything maybe a little bit messier. So, yes, we have to learn how it works, but if that's the one thing that you have a lot of problem with, I wouldn't worry about it that much. Okay, so what do I really mean when I'm talking about, say, a negative value for r? Let me see if I can get this cleaned up a little bit. Maybe I'll just get rid of this circle entirely. I was so proud of my actual circular circle too. I used a bowl, so it's actual circle, and now there it goes by. Oh well, that's life, right? All good things must come to an end. So what do I mean? Let's say I want to find a point. Let's put some points on the board. So for polar coordinates, right? So for Cartesian coordinates, we list them as x, y. For polar coordinates, we list them as r theta. Are you talking about x, y, or r theta when they give you some numbers? They should tell you. And if you don't know, you can ask. So, what about this one? 1 and 7 pi over 4. Right? So what this means, I'm always going to start here. And often you don't even have this y. I just find it easier to kind of think about it in that way. So I'm going to go out on my polar axis a distance of 1 from the origin. So here's the origin. I'm going to go out and say this is 1, a distance of 1, right? And then we go around 7 pi over 4. So what is that? pi over 4, 2 pi over 3, 4, 5, 6, 7 pi over 4. That would be here. And those are the coordinates of my point. Okay. Another one, let's do one that's negative. So what do I mean when I have a negative value? Notice for the first one, for whenever it's a positive, I'm going to go straight out. For a negative value, I'm going to go the negative direction backwards. So I'm going to go a distance of 1, but rather than going on the left, rather than going on the right, I'm going to go on the left. So I'm going to put out a distance of 1 here. That's my negative 1. And then from this point, I'm going to do pi over 2, which is going to give you this. Right? So this point has polar coordinates negative 1, pi over 2. Okay? Now, you'll notice it's kind of weird, right? Or why would you want it to say negative 1 pi over 2 when you could just do like a regular circle? You could go 3 pi over 2 around. Okay, so that's what I'm saying. These things have multiple representations. If I wanted to think about it with a positive 1, I would do 1, and then I have many options. If I want to go between 0 and 2 pi, right, I can go around all the way here to 3 pi over 2. Or I can go negative, right? I can go right back negative. So I could also write the coordinates of that point as negative pi over 2. Or if I wanted to go around multiple times, I can always add another 2 pi, right? So instead of 3 pi over 2, I could call this, so for 7 pi over 2, right? So here I found 3 different representations of this point, okay? I'm going to do the same thing with this one. I'll put it that way. Not the same, right? These 2 points are different points. Let me think about this point here. So I went this way 1 and all the way around 7 pi over 4. So this angle is 7 pi over 4, which means if I want to do this angle, it would be minus pi over 4. Right? And if I wanted to do the other kind of weird with a negative, I would go out to here, and from here to go there, that would be 3 pi over 4. So it would be negative 1 and 3 pi over 4. Okay? One of the things you'll notice, if you look at this a couple times, there's always a difference of pi, right, between the positive and the negative. Right? Okay? So if you are confused about it, you can always just memorize, like if you're confused about this going backwards and forwards, that minus r pi is the same as r theta plus pi. Or so theta minus pi if you want to do that way too. So that is one thing you can always do if you want to really just memorize that so you don't have to think about going and drawing it. Myself, I draw it because I forget things. So that's one thing you can always do. Another thing you can do, of course, is that r theta is the same as r theta plus 2 pi, right? It's also the same as r, theta minus 2 pi. You can go around whichever way you want. You can get an angle. Okay? So that's the idea with those. You can always do those. Now, both of these had a radius of 1. Of course, we can do the same thing with something that has a different radius. Let's see. How about negative 3? negative 3 m pi over 6. So if I think about it in terms of moving with the negative 3, I'm going to go out here to 3, but I'm going to go a distance of 3, but I'm going to go in the negative direction, so this would be my negative 3. And then I go pi over 6 this way, so it would be here. If I prefer to get rid of the negative, if possible, I can just literally do this, right? Pi over 6 plus pi. So this is 3, 7 pi over 6. So I go out here, my usual distance along the, let's say that's 3, right? And then my angle here is going to be 7 pi over 6, right? And as you know, my negative angle is, of course, then going to be, so this would be theta equals 7 pi over 6. If I'm going the negative, I'm going to do minus 5 pi over 6. So this is all very much related to circles, right? And we're going to be using those unit circle points. So if you're a little rusty on the the pi over 6 and the pi over 2 and the pi over 4, just go ahead and look back at your unit circle to get those back into your head. Of course, we don't have to be using those points. We can use anything. So just because, and that's an important thing to know, just because it's a pi, it doesn't necessarily mean that's the coordinates. If I can write something like 1, 2 in polar coordinates, okay? And that means that, okay, my r is 1, and then my theta is 2. Well, okay, what is that? That is not quite pi, right? Because pi is 3, so 2 is somewhere over here, right? We try to avoid that because then they're ugly, but just because it has a pi doesn't mean that it's necessarily in polar coordinates, and just because it doesn't have a pi doesn't necessarily mean that it's in Cartesian coordinates. So you do have to be careful for what you're being asked. Okay? Now, we kind of worked on, so we just drew some polar coordinates here. We also need to know how to go from Cartesian to polar and vice versa. So let me write those equations back on the board. All right, so we have x equals r cosine theta, y equals r sine theta. So if we want to find this one is in polar coordinates. So if we want to find the Cartesian coordinates, we just plug it in there, right? X equals negative 3 cosine pi over 6. So pi over 6 is here. Cosine is root 3 over 2. Negative 3 times root 3 over 2. And y equals r sine theta. So I have minus 3 times 1/2, right? So, and at least I can see that I have the point right here, right? Because both of those guys, you can see they're both negative, so they're in quadrant 3. Just works out better. So, polar Cartesian is easy. You just shove it into there. Now, let me do some the other way. The other way, you might have to do a little bit of thinking, right? Because this tangent theta, right, you have to maybe do the inverse tan. It sometimes helps even to draw it, right? So if I have something like this, 3 root 3 m3, okay? So r squared is going to be 3 root 3 squared plus 3 squared, right? So I've got 9 times 3 plus 9, so 9 times 4 is 36, right? So my R is either 6 or negative 6, okay? But in fact, if I think about drawing this, I can actually draw the point here, right? 3, 3, so 3 root 3, so this is going to be something up here. A little further, right? Okay. Now, tangent of theta is y over x, so theta is inverse tan of y over x. So this is inverse tan of 3 over 3 root 3. Okay, well, you know what that is, right? This is a unit circle point. It's either pi over 6 or pi over 3, right? So this is going to be inverse tan of 1/2 on the top, root 3 over 2 on the bottom. Right? Did I do it right? Yeah, I did it wrong, huh? Because I made the x, the y bigger, but it's the x is bigger, so actually it's down here. See? Pay attention. Anyhow, so this is going to be your, if that is your y and that's your x, this is actually, again, this is going to be pi over 6, right? Okay. So, my coordinates are theta. I can do 6 and pi over 6, right? Now, if for some reason it wanted a negative value, because sometimes it'll ask you to put in a positive value for r and a negative value for r just to prove you can do it, then you can just use that other little thing where you add pi. All right, let me write this so we can see it. I'll write this. Okay? So, so what is this, 1, 5, 6? Yeah. Okay, so you can do that. Always use that. The reason I say this can be tricky, this one was easy, right, because they were both positive, right? Well, I had both positive points, right? But do remember, like if one is negative, you can't just necessarily put it into your calculator or both are negative, right? Because tangent, inverse tan will always give you values between minus pi over 2 and pi over 2. So it's going to give you stuff that's on this side. But so if you've got your stuff on this side, you have to accordingly figure that out. Okay? So remember that back from pre-calc. We won't be doing it too much.